version optoelectronics to our customers. We have a complementary interconnect and passive business supporting the active offering. Our primary focus at CODICO is to deliver technology innovation to customers. We identify technology trends, interesting and innovative technologies. Using our hands-on experience, we try to support our customers to integrate those in their various products and applications. CODICO is pan-European, so we have a footprint across Europe with quite a lot of customers in all the major market segments. Okay, so what it is I'm working on at CODICO, it's solutions development. So on the right-hand side, you can see robotics. You can see drone examples, intelligent displays, smart displays, or computer vision or camera automation. It's just a few examples of the kind of solutions we're providing customers. The solutions are underpinned by market-leading innovative technology, and the Qualcomm Dragonwing processors are a good example of that, where we can offer customers long supply industrial grade SoCs that are highly integrated, that incorporate market leading AI performance and current consumption. We can combine the compute, AI, and camera technology with market leading connectivity for mission critical communication applications, controlling a robot at scale, or controlling robots at scale, controlling drones in extremely difficult or challenging environments. CODICO works with an ecosystem. We have an ecosystem of partners with deep experience in product development, and we leverage their capabilities, experience, and skills to complement those of our customers to deliver these solutions. And we help our customers to find the correct manufacturing locations for those platforms and solutions. Okay, so a particular requirement often when we are engaging with customers on projects is to reduce technology complexity, reduce cost and risk. And we can do that when it comes to the Qualcomm Dragonwing platforms. We can offer certified system on modules or single board computers, which are running Linux or other operating systems from the vendors you can see on our suppliers. You can see here on the left-hand side. So we have subsystems that are certified for mass production. We can combine those with engineering services where our customers need a particular skill or capability. We can combine these subsystems with engineering services proposal and work together with our customers then to deliver the products you see in the bottom right, and many more. So moving on from CODICO and talking about the main topic for today, I wanted to explore automation a little bit. I suppose at this top, let's define what I mean by automation, and that is technologies such as robotics, such as cobots, robots that work in proximity to humans, and also camera or computer vision based automation, so smart cameras. That's what we're talking about today. The global market for automation is very big, very large, and there's a very strong year-on-year growth in this segment. Naturally enough, economies are trying to find an edge over competition by incorporating robotics, cobotics, and smart cameras in industrial environments. The largest markets for automation, I think everyone can agree, is China and the US. There are many drivers for automation, and I list a few in this particular slide. Of course, I think primarily the advancements in AI, deep learning, for example, the advancements in robotics and high-speed connectivity is really enabling companies to deploy these technologies at scale. Another challenge, of course, is the rising cost of human labor. Workforces maybe are aging and labor is scarce, which is driving up cost, forcing companies to look more in depth at automating workflows. Another important aspect is sustainability. So if we're able to manufacture, for example, products more precisely and at higher quality, we can reduce waste, reduce energy, and that has a positive impact in the world. Okay. Now, when it comes to global automation trends, as I said, it's for manufacturing and other industries, it's a very competitive space globally. All of the major regions have initiatives to drive automation. China, most notably, has a 10-year strategic plan, and at the moment, I think recent reports suggest they're installing in Chinese factories, warehouses, there are up to 280,000 robots installed every year, which is very significant. The US is following closely, and they have a federal plan to help medium and small enterprises to incorporate automation technologies. Similarly, in Europe, we have a more decentralized plan, but there is support for industry through the EU's various organizations to help industries adopt new technologies to automate particular processes and workflows. And again, also India is following a similar trajectory. Okay. When it comes to scaling up automation in the workplace, in a warehouse, a factory setting, I mean, there are, I suppose, recently we've seen significant advancements in AI, for example, in the area of deep learning, and combining that with high resolution, high frame rate cameras and high speed connectivity. We have the ingredients to scale up, and in addition to that, we have significant cost savings for these technologies. These technologies have become more cheaper and accessible, so that allows factory owners, for example, to tackle some of the challenges we talked about earlier, the drivers for automation. If you have a smart camera or a computer vision automation system on a production line, for instance, so we'll focus a little bit on manufacturing here, what benefits can you expect? So when you have a camera system running at high resolution, very high resolution and frame rate, you have the possibility to almost get down to microscopic levels of defect or anomaly detection. So this means that you can become more precise about your QC or quality control, and that can have many benefits, for example, with medical device production. In addition to continuously available and flexible monitoring technologies with the combination of deep learning and cameras, you have the possibility also to increase productivity because you're not relying on the human workforce on a typical 8-hour or 12-hour shift. The cameras are running continuously, so you can enjoy the benefits of labor cost savings and increased quality control, right? Again, we're still focused on cameras running on a production line or a warehouse. these cameras can also monitor the health of the equipment on the production line, and this allows you to do predictive maintenance, so avoiding expensive line down situations. With mobile robots in the warehouse, continuously monitoring your inventory, you have the possibility to react in more real time to shortages or needs. And again, that's a benefit for an enterprise or a manufacturing company. Again, just on the technology evolution, AI, with the recent boom in AI, is very much focused on compute running in the cloud. With the recent advancements in semiconductor technologies, it's possible to have advanced, so multimodal AI workloads and advanced AI, large language and video models running on what we call edge solutions. So solutions that are embedded or integrated in devices at the warehouse level or the factory level. And moving from cloud to edge has a number of benefits when you are a number of benefits to an enterprise. I mean, you have real-time decision making. So very low latency decision making means you can react to defects, or you can react to production equipment anomalies quickly. You can minimize waste, so you're improving your sustainability, improving your costs. A very significant benefit is all of the know-how to build a product, to all of that know-how that's proprietary. That know-how can be kept at the factory and within the company, and this is very important in a competitive world. The ability as well to have low latency decision making with edge solutions means that you have the possibility to arrange robots in close proximity to the human workforce, because you can react in real time if there is any safety related hazards coming up. So from our perspective, we're at a point, from a technology perspective, a technology price point perspective, we're at a point where you do not need to invest significant R&D dollars. You do not need to engage domain experts, AI consultants and such, to deploy automation use case at the enterprise level. It's possible now to experiment and deploy these technologies with the team available at the warehouse and factory level. And we'll talk in more detail about the technologies later. Okay. But before we get into the technology opportunity, just a couple of words around the automation market within Europe. Just zooming in on that. Typically, Europe in world rankings from an automation perspective is ranked 3rd or 4th globally, but it is still a very significant market. As you can see with the year-on-year growth. We expect automation, so the combination of hardware and software technologies, to be worth about 100 billion by 2030. In Europe, there are a couple of unique constraints from the perspective of the workforce available in warehouse or manufacturing plants. We have typically higher labor costs than other regions. We have an aging workforce. We have some skills gaps in Europe in terms of the workforce understanding how to use the latest technologies. And there is a very strong focus on sustainability in Europe. So the need to reduce energy, the need to minimize waste. So these are more unique requirements for automation in Europe. In regards to the picture of automation across the continent, I want to say that we do have local market leaders. Well, we have market leaders in automation from a global perspective located here in Europe. A few companies that I've mentioned in the material here, Siemens and ABB have specialized in this area for a long time. KUKA in robotics would be another good example, a leader in the robotics field, and of course Schneider Electric. When it comes to the market areas in Europe that adopt automation, automotive and engineering are by far the largest, but we see an increasing appetite, and there's an acceleration of automation technology adoption in markets like pharma, food and beverage, and electronics, and that's increasing. So in regards to the automation picture in Europe, and when I think about how CODICO can support our customers, I want to look a little bit about I want to look at some of the major challenges briefly. We talked in a little bit of detail about some of the market leaders in Europe who have broadly adopted these technologies, but there are many other medium and small enterprises that have not embraced these technologies or don't have the skills, the knowledge, and maybe the R&D budgets to adopt these technologies. In addition, there is, in Europe, we have a challenge versus maybe the US and China in regards to the regulatory framework as well for automation adoption. Our approach is more decentralized, which means we do lack harmonized regulatory framework for using automation, and that's something that I think needs to be dealt with. But for the purposes of this presentation, I want to focus on how the technology offering we can provide can tackle the challenges, particularly uneven adoption of these technologies and the lower R&D budgets and slower innovation cycles. So based on those two challenges, I will in the coming slides explain how CODICO's offering can help customers overcome those challenges. So now that we've set the scene in regards to automation, I want to talk a little bit about computer vision based automation and what we see is the opportunity in Europe. So on the left hand side of my slide, I talk about, or we mention what's installed in warehouses and factories today. So we have equipment that is typically these days over 10 years old, based on large industrial PCs. Those PCs were hosting Intel compute, and often FPGAs were used to implement 2D custom imagers to do computer vision, backed up by software, proprietary software, rule-based software, not relying on deep learning, for example. All of this equipment was proprietary. It was quite expensive. Now at least there is an opportunity to optimize that setup. Now, instead of large industrial PCs, we can offer all-in-one embedded platforms running Linux with real-time support in the Linux kernel. The SoCs that are available today can integrate MPU, camera, compute, all in one device. The software underpinning is open source platforms. Again, I talked about Linux, and the middleware that can be hosted on Linux as the basis for these solutions. So they're a little bit more open. And then pre-integrated image sensor support, so reducing a significant workload for companies where you integrate or you take an all-in-one platform with pre-integrated support for the camera sensors, and you rely on off-the-shelf GMSL or other camera modules that can be attached to the platform. Now, the hardware, of course, is important, but it's equally important to have end-to-end AI development environments to help customers to deploy automation at scale. Okay, so that's the opportunity. We'll talk in more detail about the underpinning, the core technology. But in order to deliver on this opportunity, you need the ingredients to scale up. And from our perspective at CODICO, we have today long supply industrial grade SoCs, so core technology based on the Qualcomm Dragonwing processor family. So the hardware is complemented by software tools and AI models. So we have the core technology coming from our partner Qualcomm. Building on that core technology, we have partners developing SOMs, SBCs, and even complete platforms. And I'll talk about ours in the upcoming slides. So we have industrial subsystems customers can use to reduce development effort, cost, reduce time. To complement the customer's skills to scale up, we have a strong ecosystem of partners, very experienced in using the Qualcomm Dragonwing AI processors and connectivity. So we have partners to support the deployment. And then finally, there is a knowledge base through support, technical support forums hosted by Qualcomm and ourselves and other partners to educate engineers as they go on the journey of integrating these technologies. Now that we've talked about the ingredients that are in place to scale up computer vision based automation, I want to just say a few words about the Qualcomm Dragonwing family of processors and why they are so interesting. So we have what Qualcomm are offering are highly integrated, powerful, all-in-one platforms. These are long supply, industrial temp devices that incorporate, as I said earlier, the compute, the AI, the camera ISP all-in-one device. When we talk about the AI component, the Qualcomm Dragonwing processors are offering industry-leading AI performance, Edge AI performance and current consumption. Because the Qualcomm Dragonwing is a family, it's possible to scale up and down the processor, the NPU, the camera ISP performance, depending on the workload or use case you're interested in. When it comes to running Edge AI, these platforms can host advanced multimodal AI, so many models running concurrently, or indeed larger workloads, including large language models, can also be executed on these parts, making them very compelling. Okay, so as I said, it's an more open platform. So Qualcomm have followed a Linux first philosophy, including the possibility to make Linux more real time for processes where you have tight time constraints. Okay, so just want to show a typical example of a Qualcomm Dragonwing processor in action. Working with the Qualcomm Europe team earlier this year, we were able to get a very interesting demo working on the Qualcomm RB3 Gen 2, which is hosting the QCS 6490. So that's the high-end Dragonwing processor. So in this demonstration that I'm showing you here, in the tiles in the corner of the display, so top, bottom, right, and left, you have 4 different AI models, different tasks: object detection, semantic segmentation, pose estimation. And in the center, so let's say the middle of the screen, you have 4 video encode instances using the second camera on the RB3 Gen 2. So simultaneously, we have 4 video encodes. And finally, in the center tile, we have a video playback instance running. So just showing the flexibility, the power of these platforms, and suffice to say, the latest IQ9 family offers even more Edge AI performance and capability. So we talked a little bit about the Qualcomm Dragonwing processors that host AI for automation, but a very important component of automation is the software, and more specifically, the end-to-end AI development environment that Qualcomm can provide with Dragonwing. So Qualcomm have acquired Edge Impulse earlier this year. Edge Impulse have an environment where a customer can take one of the Qualcomm Dragonwing processors and collect training data from connected cameras on that, let's say on the development kit or platform, annotate that data inside the Edge Impulse environment, train a specific model, optimize that model, and then deploy that model to the target processor. So this significantly simplifies the development of, let's say, factory or warehouse specific use cases for AI, because you're relying on a single environment, and you're not relying on multiple tools and trying to debug those tools and such things. So this is a seamless way to deliver AI workloads to Edge AI platforms in the factory. So we've talked about the story. We've talked about the ingredients to scale, our own role in trying to scale up automation with Edge AI platforms in Europe. We are taking the ingredients, so the core technologies that I talked about, and we're packaging them into, in this case, an industrial AI camera based on the Qualcomm Dragonwing processor, the QCS6490. So with our partner JMO technology, we have developed a ruggedized production-ready industrial AI camera platform with 3 high-resolution cameras based on Sony camera sensors. This unit, combined with the Edge Impulse environment, allows our customers to experiment with application-specific AI workloads and deploying those in their warehouse application or their factory application. And we offer this kit as a means to enable customers to implement quickly the prototypes, the proof of concepts, with a hardware platform that is suitable for integration in an extreme environment, noisy, dusty environment, such as a warehouse or a factory. You can see on the bottom right-hand side, this is one of just a quick demonstration of what is possible. We have 3 cameras. The 3 high-resolution, high frame rate cameras are positioned in front of objects that in this case, these are gaskets for an industrial machine. The cameras are able to detect defects not only in the 2D plane. Because we have 3 cameras, we can do anomaly or defect detection on different surfaces simultaneously. So it reduces the need for multiple inspection stations, and increases, let's say, the output, the automation output for defect or anomaly detection. Okay, so this is CODICO's, let's say, proposition to enable automation, to enable customers to experiment, maybe to scale up integrating smart cameras or computer vision automation in their applications. Finally, I just want to show you a working case. So a factory in Asia that has deployed the Qualcomm Dragonwing cameras. This is in fabric production in Asia. So the Qualcomm Dragonwing camera, similar to the industrial AI camera in my earlier version of that camera, we have retrofitted the cameras on existing Toyota fabric production looms. And these cameras, again, high resolution, high frame rate, are continuously monitoring the output of the loom. So as fabric is being manufactured, there is the possibility of contamination. So metal objects falling into the fabric. There is the possibility of the loom having stitching errors. The cameras are running at very high resolution, can detect in real time these defects in the fabric or contamination, and the machine can be controlled in real time to minimize waste. This means that fabric manufacturers deploying this technology are offering higher quality material. They're able to minimize waste. They're also able to minimize the human resources, which in the past were monitoring these machines by the human eye. So we have a much more efficient system now through the use of computer vision automation. All of this this complete application is based on the Qualcomm Dragonwing processors and the tools and software provided by Qualcomm. So we want to replicate this kind of success for our customers throughout Europe. Okay, and that kind of sums up or wraps up my talk today. Of course, now we have some time for questions. So let's see what those questions are. Of course, there is a QR code here to allow you to, if you are interested, to get access to the industrial AI camera. And of course, CODICO is always available to provide support.
All right. Thank you, Thomas, for a really insightful presentation. The recent advances in edge processing capabilities and image processing are really amazing. So we've already got several great questions. I want to let our audience know that there's still time to submit your questions. So just do that using the Q&A tab on the right-hand side of the screen. Thomas, you ready to answer some questions?
I am ready to answer some questions, Dale. Thank you. I hope you can hear me okay. Yeah?
Yep. So
perfect.
All right.
Great.
So the first one is asking, what are the biggest advantages technically and commercially to move to Edge AI-based vision automation?
Well, the biggest advantages, I mean, from a business case perspective, I mean, I referred to it in the last slide, right? The human workforce is getting scarce and more expensive, right? So with intelligent system, with a system that has the adaptability of AI, we have the possibility to include vision-based systems where you would previously use a human operator. And of course, that system is available 24/7, right? So it's not only available on a 12-hour or 8-hour shift, right? So there's a significant commercial savings. In the fabric case, it amounted to something like a couple of $100,000 for the factory in savings, avoiding penalties, improving the fabric quality. From a technical perspective, moving from a traditional vision-based system to a system that uses deep learning principles means that you don't necessarily have to, programming of that system doesn't necessarily have to take into account small changes in the lighting, small changes in the product orientation, because the AI system is able to adapt a little bit better than a fixed or rules-based software system, right? So there's some advantages. That's probably one of the biggest advantages, combining rules-based vision systems, which have been in the market for years, enhancing those with deep learning to, let's say, to allow the machine to recover from unexpected situations with the lighting, for example. That's a big benefit technically. Yeah.
Yeah, excellent. Yeah, I can speak from experience in previous positions that lighting is a real challenge in imaging systems with the rule-based, and so yeah, that's a big benefit. So
Absolutely,
yeah.
yes. Yeah.
Our next question is, what are the biggest benefits of a company using the Perspex solution for their industrial applications?
Well, I mean, for CODICO, we recognize, I guess, the trend of, there are some challenges in manufacturing, and not only things I mentioned in the slides, but we have geopolitics, we have tariffs. So there are lots of cost challenges for manufacturers these days. We recognize that technology now is at a point where it's cheap enough and it's how would I say, capable enough of complementing the scarce human workforce, right? We wanted to package up the benefits that I talked about, not only the highly integrated SoCs with an open source base, with deep learning capabilities, but also the software environment to do end-to-end Edge AI deployments. We wanted to package that up into something that a customer could immediately use on the factory floor. So it had to be dust proof, it had to be waterproof, it had to have a proper industrial lens. So we put all of those things together to offer Perspex, and Perspec and the system we showed, Perspec 1, is the first iteration. We have others coming. And the idea was to help customers not invest hundreds of thousands of dollars to experiment with the technology, but to actually put it on the factory floor and start to capture images of what you want to monitor and use the Edge Impulse software to deploy a trained model on that hardware in situ. So we're trying to make the effort for customers to integrate this technology, which is complex, but to make it somehow a little bit more accessible, a little bit easier to use. That was the motivation, and that's what we think the benefits are for companies that will work with us on Perspec. Yeah.
Yeah, that's interesting because you've got this technology now rolling out into places and applications where they're not necessarily technology experts, and they want to apply this new technology to more traditional applications, and it needs to be user friendly. Right?
Yeah, absolutely. The key is, making this technology accessible, and we think we're at a point now. Certainly, the Qualcomm Dragonwing family and the supporting tools and software make this technology accessible to the kinds of people you talked about just now.
Yeah. Excellent. All right. Our next question is, with the rise of AI-powered quality, how do AI-powered systems such as those running on Qualcomm Dragonwing SoCs address the challenges of operating in harsh industrial environments with extended temperature ranges?
Yeah, so there are a couple of points to that, right? I guess from and it's a very good question. It covers a lot of topics. So the baseline answer is you need silicon that's going to be available, going to operate across that wide temperature range, that wide industrial temperature range, and you want that silicon to be available for 10 years, often, for equipment in the factory to get your return on investment. It needs to be around for the long term. Yeah. The Qualcomm Dragonwing brand is was developed precisely to capture that value proposition. Extended temperature range silicon available for the long term. Of course, if you're providing silicon for the long term, you need to have a software story to match. And that's there as well with a Linux base, with the possibility to patch in real-time updates, right? To make that solution available and how would I say, actuate in this extreme environment, right? I guess the central point of Perspex, everything I showed in the presentation, is the integration of the MPU. So the dedicated neural network core inside these devices, alongside the camera ISP and the other computing areas, that's central to this story, to AI-based quality control. The tools and software as well cannot be underestimated. The ability to access that silicon without hundreds of engineers is also an important aspect as well. You'll have small teams of people working on proprietary use cases. The tools and the software that make this silicon come to life have to be very capable, and the resources have to be very. The resources, the models, and such things. The quantized models, libraries of those need to be available to customize them for the many different quality control applications people are going to come up with, right?
Right.
Not sure it answers the question, Dale, but...
I think so, yeah. I think it's helpful in understanding how that industrial space is different from the commercial space, and that's a big part of it.
Yeah.
This question asking you, how big is the install base of vision automation systems globally?
Yeah, that's a question we've been trying to answer. It's not so clear in the how would I say, the market data, right? You have to come at it from different angles, but the data points that I've discovered kind of point to maybe up to 100 million systems installed across the world, right? And then when we drill down into the regions, let's say there's 30%, or a little less in Europe, 20 to 30 million systems in operation probably is on the high side, but maybe that's a reasonably realistic number. And that's the market that we're chasing that market, but we're also, with this technology, we're going from a traditional vision-based, a rules-based vision system for manufacturing, often could set a customer back maybe $100,000, perhaps less depending on configuration. We are trying to get to a cost point 10x, reduction in cost, right? So we expect to install more systems in the future. More cameras with intelligent capabilities to do the quality control, to monitor the process in assembly lines. We're expecting more cameras to be installed. So, let's say there's 100 million units installed across the world today. That's the TAM today. I expect it to grow significantly because we now have very capable silicon that's able to process locally, not in the cloud. Yeah,
very good. All right, this member of the audience is asking, they recognize the Qualcomm Snapdragon brand. Why did Qualcomm create the Dragonwing brand, and what does it stand for? I guess kind of how do they differentiate?
Yeah. So Qualcomm is very successful, and I'm talking, I guess, from just to give you a little bit of insight, we've been working with the company, with Qualcomm, for 25 years and more. Snapdragon is a brand people know about in the smartphone space. It's also the brand they use for consumer electronics, consumer audio, and you see Snapdragon most recently in Copilot PCs. I think that's been a big trend. Qualcomm entering the PC, the laptop market, quite successfully. Dragonwing is something new. Dragonwing was developed as a brand earlier this year. It's for the industrial market, and as I said earlier, it's to tell customers about a product line or a line of products, compute products, so SoCs. Connectivity as well is a very significant area of expertise for Qualcomm. So if a factory equipment supplier, if a robot manufacturer is looking for long supply, extended temperature range silicon with the supporting software and tools for those kind of applications, you go to the Dragonwing portfolio at Qualcomm. So it's a dedicated brand for the industrial market, for the extreme applications, indoor, outdoor. Yeah.
Yeah, very good. Is the Edge Impulse platform a solution offered under license by Qualcomm, and is support for the Dragonwing SoC pre-integrated?
So Dragonwing SoC family, they're a family of devices. I focused on one today, the 6490 in the middle tier. That family of devices, different configurations and development kits are pre-integrated in the Edge Impulse environment. If people listening today go online and search for the Edge Impulse landing page, you register as a user. You can immediately experiment with Edge AI in the environment online with a web-based interface. So the pre-integration for Dragonwing is there. Edge Impulse, because it's the first time, and it's the first time you really have an end-to-end environment for developing your own custom models to recognize the labels on a bottle that you're bottling at a factory, or the food packaging label, or defects as I showed in the metal gaskets. Because Edge Impulse enables that, it's licensed. It's a licensed product, so a company has to come and engage directly with Edge Impulse on licensing that technology for their applications. Okay.
All right. In the running automation example you showed at the end of your presentation, what were the major benefits for the company that deployed the cameras?
Yeah, so I mean that's a really interesting project, and it just shows how everything we talked about earlier in regards to the automation trends, making fabric has been a very manual, intense process, and over the few centuries it's become so automated. But we've now moved to a level where we can take very laborious kind of tasks, such as monitoring the loom as it's spinning the fabric for any defects in the fabric. That used to be a person on a full 8-hour shift monitoring the fabric for small defects and marking on a log where they found welts or where there's small errors in the fabric, and that's accumulated over the shift, and it's put into a report that offers the buyer an assessment of the quality of the fabric, how many defects roughly, But that is, of course, subject to all sorts of error. People get tired, people get distracted. With a camera system running at higher speed, so the loom is running faster, the camera is still monitoring and can detect all of the defects a human eye can, and more, of course. You have a higher productivity, and you remove the need for the operator to be there. An operator is still there because the machine needs intervention from time to time, as all machines need intervention on a production line. But it removes the need for a dedicated person monitoring the quality of the fabric. So it's very interesting that they can save or direct their human staff to more productive tasks, right, in the shift. But as I said, it's, I said to you earlier, you're talking about for that particular factory, they found that they're saving, I think in an average year, $200,000 and more which is pretty significant and more than pays for the hardware installation. In the first year, you're more than paying for the installed cameras.
Yeah. Well, it looks like we've covered all of our audience questions. Thank you again, Thomas, for excellent presentation and a really lively Q&A.
Thanks a lot, Dale. Appreciate it. And thanks to everyone who joined us. Thank you.
Absolutely. And before we close out this All About Embedded Systems and Edge Computing live session, I'd like to announce our prize winners for the session. Congratulations, Eric Roman and Carlos Morales. We'll be in touch with you within the next week to ensure we have the information we need to send you that All About Circuit swag bag. In a moment, you'll be redirected to CODICO's Summit Series microsite. I encourage you to check out other live sessions, keynotes, and published content for our month-long virtual event.